Thanks everybody for joining the AMS Board for Private Sector Meteorologists webinar on the importance of computer programming in the private sector. I'm your host, Mike Augustinak. I am a meteorologist at CBS in Minneapolis and also a proud graduate of the University at Albany. We will be getting underway here in just a moment. We'll give about 20 more seconds for everybody to get on. In the meantime, I'll just remind you that throughout the course of the webinar, if you want to ask a question, you can do that by using the raise hand feature, and that will add your list to a queue, and we will have plenty of time at the end of the webinar to get to some of those questions and get our experts to give their answers. We will not, however, be asking whether it's Yanny or Laurel. And if you don't know what that means, you haven't been paying close attention to social media today. I wish I didn't know what that meant. All right, so we'll start with an introduction by all of our panelists as to who they are, what their email address is, and Twitter, so that as we go through this, if you do decide that you don't want to ask a question publicly or you think of something later, you can write down those points of contact and get in touch with all of our panelists, because they have all said that they are more than happy to answer your questions even after tonight's webinar is over. So with my introduction gone already, let's start with Ryan Oates. He is our MATLAB expert. Ryan, can you give us just a brief introduction? Tell us maybe where you work and where you live and how you got started with MATLAB.
Yeah, sure. So yeah, my name is Ryan, everyone. I'm originally from Chicago, and I currently work in Chicago. I work for a company called Costco International. It's owned by a company called Costco Group in China, and we're a global commodity trading house, really on the supply chain management side. So that's just a mouthful, basically, for saying, how do we transport agriculture commodities from farm to table? And so between farm to table, there's logistics, there's a lot of trading that goes on, not just within the Midwest that we're kind of familiar with, but on a global scale. And so I joined the company about 6 years ago. I did grad school at University of Utah, and I've basically been coding and programming since, I would say, about 6 years ago now, 7 years ago. And MATLAB was just kind of the choice language at the university. So that's kind of how I got started with it. I've kind of stuck with it since.
Thanks, Ryan. And your degree, are you a meteorologist then, not a computer scientist?
Yeah. So I'm a meteorologist. My bachelor's was in meteorology at Northern Illinois University, and I got a master's in atmospheric science at University of Utah.
Great. Well, thank you. And thanks for joining us. We'll get to some questions about MATLAB in a couple of minutes. Let's next introduce Adam Turchio, who is actually on the Board for Private Sector Meteorologists, and his expertise tonight is NCL. Hi, Adam.
Hey, Mike, how are you? So thank you, everybody, for joining tonight. This should be a very fun 45 minutes or so. As Mike said, NCL is my coding choice in terms of language. I've been programming with it for about 6 or 7 years now. I'm starting to forget how long it's been and how old I am getting. So I currently work at Cargill Incorporated, based also in the Twin Cities, Minnesota. I've been there for about 2 years. Before that was at Thomson Reuters. I'm also a proud SUNY Albany graduate with a master's in atmospheric science, and also a proud NIU Husky bachelor's, also similar to Ryan Oates. I'm actually from the same town. He's just a couple years forward than I am. So what got me into NCL was really a choice between MATLAB and NCL. And at the time, Albany didn't have any MATLAB licenses left. So I was kind of given that choice. And now that I look back on it, it worked out pretty well. So I'm pretty happy with that.
Thank you, Adam. And actually, could you give us your Twitter handle and your email address?
Sure. So Twitter would be Weather Turch, or one nice thing about having a very unique name, you can search for it as well. So that is my Twitter, and email is adam_tertio@cargill.com.
Thanks. And actually, I apologize. I'll back up and ask Ryan the same thing. Ryan, can you give us your Twitter handle and your email, please?
Sure. So Twitter handle, I do not remember what it is because I don't use it too much, but my email is roates, ROATES, at COFCO, COFCO international.com.
All right. Thanks a lot, Ryan. We'll move on next to James Belanger. He is our Python expert. Hi, James.
Hi, everyone. Thanks for this opportunity to chat with you guys. Looking forward to the conversation tonight. So I have been kind of in the working in computer programming for the private sector probably for about 11 years now or so. I, similar to the other panelists, I'm a meteorologist by training. So I did my bachelor's and PhD at Georgia Tech. I also spent some time at SUNY Albany working on my master's there. So moved around quite a bit, but my background, I prefer a variety of kind of programming tools and languages depending upon the application. But what I'll be talking about tonight is how I use Python and its scalability. So my email address for anyone that wants to contact me is james.belanger@ibm.com. And my Twitter handle is James Belanger. And at the weather company, so I'm a senior meteorological scientist with the weather company, IBM Business. So IBM acquired us a couple of years back. We are interested in using kind of machine learning and data science tools to make weather forecasts better. So trying to use kind of statistics and machine learning to improve upon that raw dynamical model output. And so that kind of necessitates close interaction with programming and meteorology.
All right, thank you, James. And our final panelist to introduce this evening is Adam Frederick. His specialty is SQL, or you may have seen it written SQL. Hi, Adam, how are you?
Hello, Mike. I'm doing very well. Thanks for having me on tonight. Looking forward to being able to talk to everybody. So I don't forget, my Twitter handle is WX3Guy, and my email address is AdamF, F as in Frederick, at WebWiseWebsites.com. Kind of a little bit of a mouthful. Would love to hear Barbara Walters say that with all the W's in there. But anyway, so yep, I'm going to be talking about SQL or SQL, whichever way you want to talk about it tonight. A little bit of background on me. I actually started programming on an Apple IIe. Yes, that makes me old. Yes, I still have it in my basement as well. Don't use it anymore. But I've been into computer programming for a while. I ended up going to Iowa State University to get my meteorology degree, and then ended up going to KIMT in Mason City, Iowa, where I spent 15 and a half years as the chief meteorologist. My programming experience actually helped me to get that job. It was kind of a toss-up between me and a few other people, and they said, look, he's got this programming skills. He can do a bunch of different things. And while I was at Iowa State, I also started up my company, WebWise Solutions, and that's where I got to know Mike actually through, because we've programmed a couple CBS O&Os Weather Spotter Network program. Also have written a live weather station network system as well that has been in use on the air. And the programming has really opened a lot of doors to me, and ultimately has also, in addition to my owning and operating my WebWise Solutions business, I am also a co-worker of James. I work for the weather company and IBM Business, but I work on the media side in the as a QA in the QA department on the TrueView Max software, which also too the programming knowledge helped open the door for that position. So because I understood a little bit more about what the coders, what the engineers ended up going through. So there's a lot of opportunities that can be open to you if you just take the time to be able to learn some of the programming, and that helps to differentiate you from other people that are out there.
All right, thanks, Adam. We appreciate all the introductions this evening. Before we get started with sort of the important stuff, things that you can actually take back to your job with you or to your class with you and hopefully make use of, we do want to let you know that we do have a poll going on this evening, and we'll be opening that here shortly. It just is so that we can get a sense here of how experienced you are as an attendee to this webinar with coding. And we have some other questions as well. The poll is in progress right now. It just opened up, and you can see it on your screen there. All right. So, by the way, I have zero interest in, sorry, not zero interest, zero experience in coding, a lot of interest in it. And I'm pretty excited to see what we can learn this evening. Of course, this is meant to be sort of a primer to give you an idea maybe of which language or which of these 4 languages would be most useful for what it is you're looking to do. This webinar is not designed to make you a super user or really to even show you lines of code. It's really to sort of get you on the right track so that you can reach out and find more information about the language that's right for what it is you want to do. All right, let's start with sort of a roundtable here. I would, and Adam Frederick sort of touched on this initially. My first question is, why is coding in today's workplace important? Adam obviously got his job in part because of it, so that makes it quite important. But on sort of a larger sense, I guess let's start with Adam Frederick. Why do you think it's a good skill to have?
It's one of those things where a lot of times what an employer wants you to do, there aren't necessarily pre-made options available for you. And so sometimes you need to be able to become creative, become unique to be able to enhance what you do or even make your life easier. The old saying, work smarter, not harder. If you know how to do some programming, you can certainly easily work smarter by getting data automated into your systems or having tasks automated, and your life can be easier, and it allows you to get more stuff accomplished, making you ultimately more valuable.
Very good. Yeah, I think that as we go through the evening, hopefully the point here is to get people to realize that this addition, I mean, you can have a lot of additional skills as an employee. This one is one that is highly sought after and something that will, at the very least, help you make your job easier in some cases, even if it doesn't necessarily help the employer. Thanks, Adam. Let's go to the other Adam Turchio. What say you to that? Why is coding important in today's workplace?
Yeah, Mike. So, I mean, I'd say that coding didn't help me to get my job, to kind of walk through that door, but coding is important because, at least for me, it's helped to advance my career. I'd say that, you know, at Cargill, we're the globe's largest trader of grains, and we trade futures in terms of the grains market. So we also have a huge salt industry, fishing industry, cattle. So we have a very diverse group of employees across the globe. And as someone who can code, there's a lot of data that kind of can specifically fit each of those certain needs across the company. So the ability to really be able to transform that data into what other people can use and to kind of customize it for the needs of your employer, I'd say that that's been one of the biggest takeaways for me in terms of why coding is important. Because as we heard earlier, Adam say that it can help you get a job. And for me, I think it's helped to really increase the value that you can provide to your employer through coding.
Thanks, Adam. James, why is today's workplace in need of coding?
Yeah, it's a great question, Mike. I think you know, one of the things I come back to a lot when I hear this question is something that we say at the Weather Company, that, you know, weather means business, and so much of how businesses kind of make decisions today are impacted by weather. And so from a broad standpoint, weather and its impact on business is really a data science problem. And so how do you kind of communicate that language of data science and drive analytics, drive decision making off of it? Well, it starts having kind of that background rooted in some form of programming or coding. So for anyone that's interested in data science applications and trying to kind of make better decisions and try to understand how kind of you can take weather forecast information, weather observations to kind of change the bottom line for a company, I think it's really critical for those reasons.
And Ryan, why is coding, do you think, important in today's workplace?
Yeah, I mean, I would second basically what everyone already said. So, I mean, it's going to save you time and productivity. You know, like the first person said, you know, working smart, and also, you know, I think the world's problems and business problems and solutions are increasingly becoming more data-driven. I mean, everyone talks about big data, but it's true. And I think, Adam and I work at these huge commodity trading shops. Millions of dollars are on the line. Yeah, well, like with most businesses, I guess. And we can say, hey, rain hit Iowa, in July, but I think there's increasingly becoming larger pressure for that to be how much and where exactly. And with you get more specific, I think that requires more data usually. And so thus, I think programming is usually the most effective and efficient way to reach those solutions.
Well, Ryan, that sort of leads me to another question, and I'll ask you this in particular because MATLAB sort of is more math-based. And this is obviously going to be an ignorant question, that's why I'm asking it, but what is the difference between doing some sort of these statistical or data analyses in a program that everybody knows, like Excel? Why is it important to go beyond that? What does that get you as an end user?
Yeah, I mean, I think, in terms of one, like scalability, there's only so much you can do through Excel. Automation, I guess VBA, you can get a certain degree of automation as well, but from my knowledge, it's easier if you use a Python or a MATLAB environment for that, or any other language. And when I went into grad school, my professor asked me to pull raw data from the global climate model, and I've quickly realized that using Excel would be extremely cumbersome to reach the objectives that he wanted in our research. So again, it goes back, I think, to me, saving time and increased efficiency, and even I think just doing it in an Excel environment. I think some things are just not possible in that environment, with especially in atmospheric science.
That sort of gets me to this question, Ryan, which is, it sounds to me like maybe your first introduction to coding, was that in grad school or was it as an undergrad?
So it wasn't undergrad, but I'll be the first to confess to everyone here that, I took C++ and didn't think it was relevant to anything. In fact, I had my buddies help me with my homework. and so I just kind of coasted through undergrad. We did do some MATLAB in our dynamics course in undergrad. But again, I felt like, well, why do I need this? And then, again, I hit grad school. And I guess I just didn't really because I didn't see the reason for it, at least as a naive undergrad, I didn't see the importance. And so it wasn't until grad school, like I said, where my stubborn German professor was saying, you must do this. And I was very reluctant, but again, quickly realized just the power of computer programming when you need to pull gigabytes of data very quickly and analyze it, visualize it. It's just so much easier in the MATLAB environment that we were using.
I wonder, as we go through the next groups of questions here, if anybody sort of can expound on what Ryan said regarding when and why they sort of got into coding in the first place. I'll just sort of open the floor to the panelists.
I'll actually jump in for that, Mike, because I took that same C++ class Ryan did a couple years later, and I thought the same thing. It was just, basically just force feeding you lines of bland code, and I also got help from buddies to just get it done, to just get through that class, because I didn't see the practicality or the end use of that coding, and to really see exactly why it mattered. I just saw it as just a quiz that I had to get through, and it really wasn't until I got to grad school and my advisor, Lance Bozart, had asked me just to do some help with a presentation that he was giving, and I looked at what these other grad students were doing, and they were coding, and they were making these really just very gorgeous maps. They were able to take vast, incredible amounts of data, transform it, and create something that just looked absolutely fantastic. So for me, that was when I had that aha moment where I realized this is what coding is for. This is what coding can do. I got a lot of help from my grad student peers, and that would be one advice. And I know that we'll get into advice later, but just one piece of advice that I would offer now that I think is the most important is that as you have others around you who are also coding, lean on them, ask them questions, ask them to show you through exactly how this coding thing works, because it is hard, but if you lean on each other, it can get you through and help you to create some really useful, practical things.
I do want to open up our next poll question as well, which sort of ties into this, and that is how many years of coding, for those of you who do code, who are in the audience right now, did it take you to feel comfortable in the language that you code in? So again, the poll questions remain open through the webinar. Also, we are excited to take your questions, so you can send those to us via the text interface and by raising your hand. I think I'd actually like to move on to sort of the next point here on our agenda, at least off the top. And even though all of you gentlemen program in different languages, I would guess that there are some common lessons that are learned when you hit a roadblock in whatever it is, the language that you're writing in. So who has some epic fails and things that they've learned from them to share with the group?
I have one, Mike, that is a very simple one, but I can think back to my first year at grad school when I was trying to get into NCL and coding, and I remember that I had the script completely written at about 7 o'clock at night, and I thought that I had it done, and I hit run, and it just didn't process through, and I stayed until about 7:30 the next morning. I just stayed overnight because I was so frustrated that I couldn't get this thing through. And finally, when another grad student came in, I asked him to take a look at my code, and the error was I had one word capitalized and it shouldn't have been. So I think for me, that was just one very hard lesson, but one very important lesson to sometimes just take a step back and take a look at the big picture and look for some very minor flaws in your code that can lead to these very large consequences. All right, and looks like we have Mike's audio just cut out. So do any of the other panelists have any important lessons that they've learned from coding?
One thing that I have learned over the years is don't be afraid of trying different languages. What my opinion has been is that when you learn to program, you learn the basic concept idea of, okay, you got to break this down into very simple steps so that way the computer can understand it. Obviously, it can get to be very complex as well, but it's still, every single command is a very simple step. Sometimes you've got different languages that will benefit you and make life easier in one area, life easier in another. So don't necessarily say, oh, I'm sitting down learning C++, therefore everything I have to do in life I need to do as C++. I mean, for me, I think back, I started with the Apple Basic, Visual Basic, Perl, I've done some Python, I've done some PHP, I've done C++, I've done a bunch of different things, all depending upon what was actually needed at that point, with obviously SQL being one of the things I talk about tonight.
Yeah, I'd like to just echo that point, Adam. I can remember when I first started, I actually started in MATLAB, and then gradually shifted to other applications and languages. And one of the things that can be a challenge is having to code something from scratch where another language might have a library or module already built. And so that's one of the lessons that I had to learn the hard way in grad school, trying to work with like QG vorticity equation, trying to code that in MATLAB, and then having the pieces already kind of built or that you could use in NCL or Python. So I think it's important to kind of take a step back and understand what resources are available, and it can certainly help make your life a lot easier.
Thank you. So Ryan, is there any lesson that you would like to share with the audience before we go to the next question?
Yeah, I mean, I would just say my biggest mistake probably was not asking for help sooner, or simply just using Google to look up a solution to a coding snag. And I think half of that is just learning to ask the right questions, learning to use the right lingo. Yeah, I had to learn. I didn't even know what the word at first. The word vector or matrix was. It was just a foreign word to me. So I was asking things in the wrong type of lingo. So it just takes time, but I think you can pick up things a little bit quicker just by seeing what's already out there through GitHub or MathWorks. That's a kind of in-house support chat there. So I think just that's my biggest kind of regret or mistake. Maybe is just not asking sooner for help.
And I guess I'd like to add one more thing too is, don't be intimidated and feel that in order to do something in a different language, you have to be an expert in it. Sometimes, your task may be fairly simple, and using a different language you don't have to become an expert, but you can know and quickly learn enough to get the job done.
It's a great point. I mean, I think it's also something that can be said that if you are fluent in one language, then you may not be able to code in a separate language, but you may kind of understand the basic gist of the framework or the basic functionality of what that language is trying to do. So I kind of say that, if I can program in Python, NCL to me is like if I'm fluent in Spanish, it's Portuguese. So I can kind of understand it. I can't speak fluent Portuguese, but I get the basic gist of it. So that's a very, very good point as well.
Shall we move on to each of the individual languages, and we'll have each of you sort of, in addition to talking about how you use the language, also give us some advice for people who are starting off in that language, be it students or people who are already in the workforce, because you guys know this the best. You are the experts. So we will start with, let's start with Ryan for MATLAB. Ryan, go ahead and give us the 5-minute pitch on your programming language.
Well, I'll start as a pitch and then might not end as a pitch. But basically, MATLAB, as you can see, it's a high-level proprietary programming language. Basically, meaning MATLAB is a company, and they've developed out the language, and they own and issue the licenses. And it's used mostly, I would say, in the engineering and sciences. At least that's kind of the people that know what MATLAB is. Usually they're in some type of physical science, astronomy, or some type of engineering. And one thing, I could be a little bit biased on this, but one thing that a few positives is it's really easy syntax. I started out in actually a language called IDL, which is very similar to MATLAB in the syntax. So maybe I'm a little bit biased, but it's very clean and simple. Functions there's a lot of functions already built into MATLAB, and so when you're an early programmer, I mean, Adam Tercio mentioned this earlier about he spent the whole night looking at just for one small error. And one thing I like about MATLAB is the syntax is very forgiving, and when you do have an error, MATLAB's really good at pinpointing obviously the exact line and what could be wrong, and so you can find your errors really quickly. And so debugging is, I think, really efficient in MATLAB. There's user interface. Again, it comes with MATLAB. So when you say MATLAB, it's not just the language; it also includes a user interface that's imaged on the right-hand side. And it's really, again, simple. You have your variables on the right-hand column. You can visualize the vector, table, or matrix in the upper center window there. So it was really interactive, and I really appreciated that. Again, universities, I think this is where most of us were exposed to MATLAB, and like Adam and I in a dynamics course. And so it's pretty it's pretty widespread, and it creates, again, if you're asking a coworker or I should say a classmate, everyone kind of has a familiarity with MATLAB. So I think that's definitely a pro in terms of starting with the language, and it's matrix based. And what do I mean by that? Basically, if it's x equals 1, that's a 1-by-1 matrix. And so I think when in the physical sciences, we use matrix a lot, and I found it rather easy to use them. Now you can do that in Python, but you also have to add, I think they're called toolboxes or they're packages. You have to add additional things, but this comes very intuitively with MATLAB. So let's go with some cons now. After university, so a student license, as you guys probably know, is around $50, and that might even get you all the toolboxes in MATLAB as well. But after university, it becomes quite expensive. Just the basic license is $3,000. Every toolbox in addition is $1,500, and it's something where if you're trying to pitch this to maybe your boss, if he doesn't understand MATLAB or the power of programming, like especially like me in the finance world, it is a struggle to get the $5,000-$6,000 to get all the packages and the licensing that you need. So that is drawback, I think, and because again it's proprietary, it's not necessarily open source. So I can't really share my code with somebody else unless they also have a MATLAB license. In terms of now, you can write a function and you have a standalone application and a compiler. Again, you have to cough up a little more money for that feature. And so it is there. It's just a little more difficult, especially the developer community is a little bit more limited because, again, it's proprietary. And I say this relative to, let's say, a Python. MATLAB's been around for, I think since the early 80s. So there is a rich history of developers in the field, but it's not nearly as widespread as an R or a Python. So my recommendation is if you're just starting in coding, I would recommend MATLAB just because it's cheap and it's easy. Especially, you'll probably use it in the dynamics course already. And so I think that's a good, I'll call it a gateway language to programming. If you have some experience, I'm currently making a transition over to Python. So I think after you have some experience, I think it's just going to be a little bit easier, especially, let's say, if your company doesn't fund MATLAB, or if it's sometimes difficult to run MATLAB on the cloud. You have Jupyter Notebook for Python. You also have a great user interface called Anaconda or Spider with Python that is very similar to MATLAB. So I think some of the positives that I had, the reason why I stayed, through time, I think Python is giving me less reasons for me to stay with MATLAB. So that's kind of my pitch for the language.
Thanks, Ryan. And as we continue to go through one by one each of the languages, I want to open up another poll question for everybody in the audience, and that is pretty simple. What's your coding language of preference? We have MATLAB, Python, NCL, or other. And we are getting questions. We appreciate those. We will answer those toward the end of the webinar. Feel free to submit those at any time. All right, let's move on to our next panelist, and we will talk a little bit about NCL. Dr. Oh, sorry, Adam.
Mike, can you hear me?
Yeah,
yes.
I hear you. So tell us a little bit about NCL.
Okay, thank you. So NCL, as I said earlier, was something that I kind of stumbled into because I heard that I had the choice between NCL and a MATLAB. And NCL has been a very, very useful tool for me. It's been around since, I believe, the early 90s, so it also has a very rich and deep history. And what I like the most about it is that it's geared towards the atmospheric scientists. It's built by the atmospheric community for the atmospheric science users, both private sector, academia. It really spreads the entire spectrum of what our field really is, and what it's capable of is really fantastic. So just kind of going through the list of pros, the biggest one is that it's free. It's completely open source. It's NCAR, UCAR, so it's something that is provided by the government. So everything is completely open source, which is just fantastic. So that kind of allows you to dive into the actual nuts and bolts, and it doesn't really restrict what you can do with NCL language itself. Another pro is that it creates really just absolutely beautiful graphics very quickly without really much work that can be required from some other languages to kind of make everything presentation ready. So the graphical interface, the graphical options, you can use color tables from MATLAB, Python. They have their own very, very wide assortment of options as well to choose from. And as I said, the functionality geared towards the atmospheric science community is where a lot of the work that you might have to do. So James mentioned with, I believe it was, I'm blanking out here, Q vectors or PVA, something like that, that you may have to code by hand in some other languages. NCL likely has some sort of functionality that's built in. So it's an interpreted language, which means that a lot of these functions are done for you. So if you want to look at your EOF of your North Pacific sea surface temperatures for a couple of months per year, there's a function for that. If you want to look at Q vector analysis, add some crop impact functions that the team has built out lately, then that's an option for you. And I'd say that the final and most important, well, very important pro next to free is that the support community is just fantastic. There's an email list, NCL Talk. If you go to the ncl.ucar.edu website there, sign up for that. It's a fantastic resource, and pretty much if you have any question, you can email it, and then that day, if not the next day, you will get an email back to you and to the entire group that's sent out that will answer your question. So I've used that several times. I've been able to answer some questions on that. The NCL team, which is just a very informative team. I mean, they are the ones who built this thing out and who write the updates, will actually respond directly to you. So make sure to use that. It's a fantastic resource. The example page is just also very, very rich. They'll give you the exact skeleton, download that, use it, learn how these functionalities works, learn what each line does, line by line, going from top to bottom, and then adjust it. So start with that skeleton, add meat to those bones, and then you'll actually build out a really, really useful, great script from really something that starts as a very, very simple line of code that then will just expand with time. I'd say that the cons is that you can't exactly customize it as much. As I said, it's an interpreted language, so the functionalities are written for you. So if you do want to tweak some of them, then you have to go into the actual functions. You can change them, but I believe that it is written in either C or Fortran, so you may have to get into some of the really, very technical languages as well. Another con is it's not as fast because it is interpreted. You can't parallelize it easily or at all, something that we might look into, but that's something that we really don't, that can slow things down a little bit. So because of that, the computational demand could be high. And I'd say that my biggest advice to students is just dive in. On the NCL website, they have support with some PowerPoints that you can just go into. They'll guide you step by step, show you how to install the program. You can install it on any PC, Linux, or Mac. So once you get on there, download it, go through the steps, see how everything runs, download a script, and that feeling when you actually get to code and successfully go through your first script and produce an output that you can use is just a fantastic feeling. So just dive in, use it, and use the active support community to really build off of this fantastic language.
Adam, in terms of the actual raw data that you're processing from, say, NOAA or what have you, all of that stuff you just pull that from the central repository, right?
Yeah, so you can either, download data, and I actually use NCL to just download data. You can read data online using the OpenDAP functionality as well. So really, it opens up the door to endless amounts of data that then you can access, which, as I mentioned, when you work for a very large corporation, there may be a lot of different needs that you don't really expect to coming into the job. So the ability to pull from a lot of different data sources, whether it's NASA, NOAA, the ECMWF, it's all really, it's a very useful tool to be able to access and interpret all of that data.
All right, thanks, Adam. Before we move on to James and Python, we will open up the next poll question for everybody in the audience. And that is, of the listed languages, which would you like to know more about? And you see your options there. And we're getting some great questions. We will get to those. But first, we do want to talk with James. James, give us the sales pitch on Python.
Sure thing, Mike. So Python is probably one of that. When you hear that language, everyone it perks their ears a bit. It's definitely been growing in popularity in the I guess the past decade or more. I actually began programming in Python about 6 years ago, and I similar to Ryan, I have a background in MATLAB. That's how I started. And one of the nice things that Python allows you to do is sort of because it's an open source framework. What it does is there has the capability to import modules and libraries that other developers have created, which is really useful in the context of trying to ingest government model source of data that's often distributed in GRIB or GRIB1 or GRIB2 format, and things like MATLAB can't natively ingest it. And you need kind of wrapper utilities written to be able to work with the data. So I found myself gravitating to Python because of the libraries and modules that had been built to handle GRIB data using like the PyGRIB modules. And so it's similar to NCL, though. It is an interpreted high-level programming language, so it's already kind of compiled for you. You don't you're not compiling any code yourself, but it's really easy to use, easy to learn, especially for non-programmers. I find a lot of times people that have no programming background can start kind of fresh in Python and pick it up rather quickly. The code has an object-oriented based approach, which allows you to kind of apply methods and functions to objects. Because it's modular, you can import a vast variety of different libraries. Some of the more popular ones are things like pandas and Xarray for those that are interested in doing data science applications. So there's a wide variety of support for multiple variety of computer platforms, whether you're on a Mac, a PC, or in a Linux environment. So I found myself using Python because I needed something to interact with GRIB really well, and I was interested in trying to create nice graphics for visualization. NCL is certainly a great tool for that. Python is also great at creating really fantastic visualizations, and using modules like Matplotlib. And I think Ryan pointed this out earlier. There's packages packages that kind of bundle a variety of these essential modules together. If you kind of go to the Anaconda website, you can pull the Anaconda version of Python, and that's a really great way if you're just getting started out and you're not really sure which which modules you want to use, and you want to kind of have a good framework to use from, I really recommend that Anaconda package manager. So in terms of the cons, so at the weather company, and at least in the forecasting sciences team, where we're prototyping new methods and algorithms to improve our weather forecast, we actually are a MATLAB shop. So we do a lot of that in MATLAB prototyping because of the dimensionality of the data that we're working with, multi-dimensional data. MATLAB is just hands down faster than Python. It's much slower, and it's also can be very memory intensive. It's a lot of times you have to be careful about how you're structuring your memory allocations, whereas in other languages you can be a bit more, it comes a bit more easier. The other thing I'll mention is up until recently, multi-processor, multi-core support have been kind of rather limited. Now the Dask modules has certainly opened the door for sort of parallel processing and high performance computing environments. But in our applications, what we end up doing is we a lot of times we'll compile MATLAB code and then we'll be able to distribute it on an HPC environment. That said, Python is a lot easier to distribute if you're running like cloud applications. So it's really easy to distribute to a new cloud system that you might stand up. And I guess another last con is for anyone interested in mobile computing, generally it's thought that Python's a bit weaker in that, so may not be the best language if that's your interest.
Thanks, James. Coming up next, we'll hear a little bit about SQL from Adam Frederick, but I do want to introduce a new poll question as we get started with Adam here. And that one says, which sector of meteorology are you pursuing a career in? If employed, choose the best option matching your current occupation. So that, again, is for the audience, and we appreciate you guys answering these polls. We'll give the results a little later. All right, Adam, tell us about SQL.
Well, thanks a lot, Mike. SQL is not necessarily a language that you sit down per se and you write applications in. SQL is a database system. It stands for Structured Query Language, and it's really designed as a way for being able to be kind of a standard in many regards for being able to make queries to databases to be able to pull data out. And obviously with weather and a lot of data that comes in by way of weather, being able to get that information in an effective, quick method is very important. Now, a lot of times you would use something else, like you would use Python or you would use PHP or another language to be able to write a program that ultimately will end up interacting with your SQL database. And so it's the most common standardized language out there that's available for databases. Now, some of the pros about this is that the SQL database servers are typically very fast and very reliable, great ways of being able to store large amounts of data. And again, especially with weather data, that's very important because we've obviously got to be able to store the data and then be able to retrieve it back in a very quick method. Some of the good stuff about that too is that you have things like MySQL, which is an open source and free option that you can use, or you can simply go and you can get a cPanel hosting plan that maybe you're paying a couple bucks a month, and you would have access to be able to, they already have, MySQL set up, so you can just simply use PHP and write an app that sends data, retrieves data, and whatnot. There is some disadvantages though to this. Different vendors have different advanced proprietary features based upon their software. So Microsoft has, their SQL Server, and there's things that you can do, functions, commands, different things that you can do inside their SQL that maybe doesn't transfer directly over. So it might be something where it's like, oh, great, the Microsoft solution will work very well. But on the flip side, oh, well, we want to start saving money on licenses of Microsoft, SQL Server. Well, you can't necessarily just go and switch it over to MySQL if you've taken advantage of some of those. But we have used this before in lots of things, like I have the pictures there, for example, Mike with his Weather Watcher network that we have done for him and for some of the other spotter networks that are out there, of being able to send the data and retrieve it. And as I said earlier, you typically don't just sit down and write it. So we used what's Ajax Ajax is typically going to be your HTML, CSS, combine that with JavaScript, combine that with SQL, and that's where you get into how you can effectively take the data, store the data, retrieve the data, and make use of the data in some other way. So being able to touch all those different programming languages and understand how they all interact is also sounds very important. But again, it's a powerful language and it doesn't take much to be able to get into learning some of the basics.
So Adam, just to clarify, SQL, you would never write a program that simply used the SQL query and that was the final result of your program. Your SQL programming would then feed, would store and pull data from the database and feed it to another interface that the public would interact with. Is that a fair thing to say?
That's a very fair statement. You know, and I mentioned the Ajax. One of the first ones to use that was Netflix, where you could hit add to queue, and as opposed to the page reloading, it would use the HTML, CSS. It would make a JavaScript request to the PHP database, which would then have the SQL command to go pull the appropriate data or store the appropriate data, send the response back, and then display it. So yes, you wouldn't sit down and just program something strictly in SQL. Usually you've got something else that you're using to interface with it.
Great. Well, thanks to all of our experts for giving us the rundown on each of their programming languages. Reminder that at the end of the webinar, you'll be able to download a PDF version both of the webinar, a PDF version of a handout, which has some additional resources that you can go to learn more about these individual languages. But then we also are offering up the PowerPoint slides as well that you can download. I want to get to a few questions before we go. A few of these programming languages like NCL and Python were described sort of as higher level languages. If you remember, even from your middle school or high school computing classes, that, you know, there's machine language, which essentially is ones and zeros or one step above that. There's sort of an intermediary programming language, which maybe depending on your age was Fortran or C++, and then this NCL and Python are somewhat higher level programming languages where you do not necessarily need to get into telling the computer how to make the computations. Somebody has already built a module for you to do that, and your programming is calling on those pre-existing modules and having them work together to get you whatever the result is that you want. So one of our questions from Hammond Thornton is, and I'll open this up to the entire group, what is your opinion on C++? Because certainly when I was younger, both in undergrad and in high school, that was the language that we were told we should have been learning. Is it still relevant? Is it still useful?
Mike, I'll take a stab at this question. A lot of times when we, at least in the weather company on the forecasting sciences side, we will spend time doing prototyping of new methods in a high level language, like whether that's NCL, whether that's MATLAB or Python. But then when it comes to actually having to implement something in real time that's going to feed, you know, potentially thousands or millions of requests, you know, at a millisecond response level, a lot of that programming is done at a more, like, you know, using your terminology, at an interactive, intermediate type of level. So we have software developers that are programming in C++ that will sort of take prototypes of code that we may have written in MATLAB and then translate it into C++ to get it implemented into a real-time, like, running operational application. So I think to get back to the question, I think it depends on the use of the application. If it's really just for sort of prototyping or maybe research purposes, you know, Python, MATLAB, or NCL would be great resources there. If you're really looking for something where speed is important, that's when you're going to want to think about C and C++, where you can actually compile the applications you're building.
Yeah, I'd just say speed, you know, speed for C or C or C++ or Fortran is something that these higher level, you know, wrapper languages really can't touch. So if you are trying to do something just very, very fast, then I think that's where those languages certainly come in handy. And just because they are older doesn't make them any worse. They certainly still do have their place in the coding world. You know, these higher level languages are still based on those more fundamental languages like C, C++, and Fortran.
Great, thank you for your answers on that question. Let's move on to another question here. This one's from Mariana Scott. Graduate schools often push expensive proprietary languages like IDL or MATLAB. How important is it to push back against the norms and request that the professors use more open source languages? And maybe Ryan, we'll put target this one to you, since you said you're kind of moving away from MATLAB now.
Yeah, so, you know, I think we mentioned it earlier, it's easy to just continue with what you're familiar with. And I'm not saying all professors are old, but especially later in life, I think it's easy just to keep doing what you've been doing. And so I think that's a really good question because, you know, honestly, I think a lot of, again, I don't know every professor, obviously, or where they're at, but it seems to me that they've started there, you know, you're a 4 to 6 year student with them, and they'll prefer you just use the language that they use. And they're the tenured professor. I would just maybe, I think for a really stubborn professor, it's a matter of planting seeds. And the open-minded ones will make the conversion. But I would just push, especially if you already know Python or an open source language. Hey, you know, tell your professor, hey, I can do this exact same thing. In fact, I think there's some functions that might even make your life easier down the road. So I think that's the way to pitch that. Personally, my professor would probably just continue in IDL. And so I think that might be a lost cause on my side, but I think that's the angle you would take.
You could make the argument as well that this language becomes dead to me after graduating if I have to spend $3,000 on a license myself instead of $50 for a student license.
Yeah, I think that's a good angle as well. Yep.
It looks like Amana, or maybe it's Amanda with a typo, asked the question that's, what is the most useful way to learn a new programming language after you've graduated? So we've learned some of these in school, but maybe now from this webinar we want to change. Again, I'll open it up to the floor. Is it YouTube videos? Is it actually paying to take a class? What's your suggestion?
I guess if you don't mind, Mike, I'll take that. The reason being is I learned C++ in college. I did independent study in college on Visual Basic. Otherwise, all the other programming that I have learned has been on my own. And I didn't necessarily sit down and watch YouTube videos, but there's a lot of good sites out there that you can sit down and it will walk you through it step by step, starting with your simple hello world. How do you display something? How do you print something off? To, you know, here's how you do that. Here's how you go through and make a basic program. And once you kind of get the basics, you just kind of keep adding to your toolkit from there. And, you know, I wouldn't necessarily sit down and say I'm an expert really at any one programming language, but I have the fundamental basics of a lot of them. So when I run across something of, oh, I need to do this, I learn it at that point in the language of what I need to learn it in. So sitting down, finding a good site, and being able to just kind of work through some of the basics is the best way that I've always felt.
Yeah, one thing that I can speak to is that for NCL, as I mentioned, those example scripts, they really start from the very, very basic, simple, hello world, and then slowly move on forward with time. What I would also recommend is that NCL offers some PowerPoints online that will kind of walk you through everything, some previous presentations that the NCL team has provided online. And once you start to get into it, they do offer workshops. So you have a nice excuse to go to Boulder, which is great any time of year. So I'd say that that's really one option as well, is that once you start to get into it, you can go for, I believe it's a 2 or 3 day course in person, but you certainly don't have to do that. There's plenty of online resources to use, especially if you do know somebody who uses NCL or Python, then you can start to code and then talk to them and send code back and forth. And I think that the key here is just to collaborate, and it'll make you learning a new language, especially after grad school, much, much easier if you have a coding buddy, let's say.
Picking up off the theme of what Adam just mentioned about online resources, one that I would recommend for those that might be interested in more of a data science meteorology slant to programming, a nice resource it's called cognitiveclass.ai, and it's a free course sign up. And what you can do is you can earn badges. That's the equivalent of kind of course credit. And at least within IBM, we actually view those kind of credits as equivalent to what you might find at a college or university level. So there are things like Python for Data Science 1, Python for Data Science 2, and I personally found them to be really nice resources, especially for some of those concepts that may not be familiar yet, like big data is a growing field right now, and how you use tools like Hadoop and Scala and those kinds of things. This cognitiveclass.ai is a great online resource for those of you that may not be able to get somewhere for an in-person class, but is looking for something to do on the side.
So James, you mentioned another language that another audience member asked about. Scala, I think it's Clojure. We had a question about grads. Certainly, we've all probably heard of Genpact. Now, we knew when we made this webinar that we were not going to be able to tackle all of the programming languages out there, but we did try to pick some of the most useful ones for now, at this point in time. Does anybody have any other, if we could have expanded this webinar to 10 panelists and added a few more languages, are there any others that you think are still worth learning at this point?
I guess from my perspective, doing a lot of stuff in regards to things that are public facing, PHP is a very good language that is very web friendly and is very friendly for being able to interface with SQL as well, and also being able to use JavaScript calls and everything to access it. So if you're looking at doing something that is going to be more public facing, being able to learn PHP along with SQL is definitely beneficial.
R is another pretty popular language, especially this is maybe less in the sciences and more in the finance world. It's a great statistical language.
Yeah, I'd echo the point about R. There's a lot of nice overlap and interaction with Python. So for those of you that are interested in statistics, I'd definitely check that one out as well.
I would also say R. R certainly, from more of a statistical standpoint, I'd say is another very good language, especially because that has a pretty easy to use interface. So R may not be your answer for everything, but I would say that also given the interface that it does have with the GUI, similar in some ways to MATLAB, but it's R is free and R is completely open source. R might also be another good language to start out on, just to kind of get your feet wet, and then you can move on to some other languages that you might find interesting.
That was another question we had for our panelists. Oh, sorry, go ahead.
But I just wanted to add one more language, and this is more of an up and coming one potentially. Julia, Julia. It's actually created by, I believe, the developers, founders of Python, and they wanted to create a language that's nearly as fast as C, but has a syntax and simplicity of a MATLAB or a Python. So, do your research. The development community is very young on that, but maybe in 10 years it could be, the next Python potentially. Just very widespread.
Thanks. so that sort of touches on next question. I'd just like to sort of go down the list here. We'll start with Ryan. Somebody comes to you, regardless of their age, they're like, I'm going to learn my first programming language. Ryan, what do you tell them should be the first one in your opinion?
You know, if either MATLAB or Python, just again for the simple syntax, that would be my probably go-to. At the end of the day, though, if I had to pick one, you know, I probably would say Python, just because again, MATLAB is expensive, and yeah, I think there's more opportunities in the Python language right now.
Adam Turchio, I'm going to hold your feet to the fire too. You have to pick one. Which one is it?
I'm going to go with NCL still. You know, I think that between the really good user community, you know, the online resources, you can even look back on previous questions. You can Google and you can see from that NCL chat going back to the early 2000s with questions that people have asked before. There is a good community of users across the academic and private sectors as well. That being said, you can't go wrong with Python. Python is and NCL and Python are starting to work together more closely. I know that that's something that the team is also trying to push towards. So NCL would be my answer, but I would also say that you cannot go wrong with Python.
James?
I'm going to say Fortran 77. I think if I were starting out or recommending someone who's just now starting out to start with Python, it just the scalability and usability and it being open source, it's really a great starting point.
And Adam, well, you said PHP, right?
I was going to say being the front end as opposed to the research oriented, being more the web server kind of side of things. Yeah, PHP is the way that I would definitely go. But again, that's not going to be necessarily as efficient for doing some of the stuff that the other gentlemen are doing.
All right. One other reminder that at the end of this webinar, or even now, you can download our 2 handouts. And again, on those handouts, for those of you asking, well, where should I go to get an online course in this or to learn more? All of our programming languages have links to learn more. Another resource aside from YouTube, which who knew it would ever be used for anything more than cat videos, but there actually are some great videos out there for programming advice on YouTube. There's another site though called lynda.com. It's Lynda, and essentially it's the professionals version of training videos on YouTube. It's run by LinkedIn, and CBS has essentially offers nothing to its employees except the ability to work on weekends and holidays, but they do actually offer us a free subscription to Lynda. So if CBS is doing it, chances are if you work for a company, they may have some sort of relationship with lynda.com as well, and you might want to check that out. Before I let everybody go, I do want to go through the poll questions that we have been asking off and on throughout the webinar, and we'll get some of the results here. First one, how many years of coding experience do you have? Everybody here has at least a little bit, or at least everybody who responded has a little bit of coding experience, so that's good to know. And it's pretty equally split between sort of newbies, noobs, and those who have been using it for more than 5 years. How many years of coding did it take you to feel comfortable to code in the language that you write in? A third of respondents, or just shy of that, still don't feel comfortable or are pretty new at coding. The vast majority of you said that you picked it up after 1 to 3 years. So a relatively short time investment if something like that can take you through your entire career. Here's our third poll question. What is your coding language of preference? Python won this one with about 50% of respondents feeling that Python is the best one to use. MATLAB, a close second. NCL was on the list at 8%, and then other. Unfortunately, we don't know which languages are included in the other, but other was got 19% of the votes. And then our final question, of the listed languages, which would you like to learn more about? Sadly, there's not a single soul who wants to learn any more about MATLAB. Okay, but at least we all know that now, right? Python, about 2/3 of people want to learn more about Python, about 1/3 want to learn more about NCL, and 3% want to learn more about some other language. Oh, sorry, there is one last poll question. Which sector of meteorology are you pursuing a career in? If employed, choose the best option or the option that best matches your current occupation. About 20% of people in our audience are going into or are in academia. About a quarter are in government, including operational forecasting or research. 18% are in the research sector, and about 4 in 10, 38% are in the private sector. Those are all our poll results. And thanks to everybody who took the time to answer those questions. Thanks to everybody who was on our panel, including Ryan Oates, Adam Turchio, James Belanger, and Adam Frederick. Again, guys, why don't we go through the list one more time? Each of you give us your email and Twitter for those who may have joined late, starting with Ryan.
Sure. R. Oates at COFCO International, so ROATES at COFCOinternational.com.
Adam Turchio.
Twitter name Weather Turch is the Twitter, and Adam_Turchio at Cargill.com for my email.
James?
Email is james.belanger at IBM.com, and my Twitter handle is James Belanger.
And Adam Frederick.
Twitter handle is WX3Guy, and my email address is AdamF, F as in Frederick, at webwisewebsites.com, and that's plural, or if you do a singular, it'll still work as well, but AdamF at webwisewebsites.com.
And I am Mike Augustinak on Twitter. That's M-I-K-E, then spell August, like the month, and the program should autofill the rest of it for you. My email address, the best one to get me is actually probably my work address, so that's Mike Aug, M-I-K-E-A-U-G, at WCCO.com. Thanks for your time. Thanks for your questions. And again, please reach out to us individually if you have more.